Good morning, folks. So we are starting a new section or a new whole chapter with this week and probably a little bit into next week. It is titled Conic Sections. Specifically, the lesson we're starting with is circles, which doesn't seem too intimidating. We're just going to be working with simple equations of them and finding equations of them and graphing them. Probably the focus just from remote learning is likely going to be a little bit more of the equation side of things because I don't know how best to assess graphing. That being said, conic sections are basically, if you imagine the word conic came from the word cone, right? This little 3D best representation I can, cone. And a section is really a cross section, meaning if you ever go to the supermarket and that deli machine that slices the blocks of cheeses into really thin slices, if we were to put a cone through one of those deli machines and the slice that came out would be what our conic sections are. So if we held the cone perfectly straight and sliced right across it, that slice here would look like a circle, okay? Obviously, I'm trying to represent a three-dimensional object on 2 dimensions here, and my art is not 100% perfect here. But the good news is you won't need to draw this. You just need to know that these objects are basically all hidden somewhere within a cone. So circles are pretty straightforward. We have a quick definition of them. This is good for reference sake. You're not going to be quizzed on the definition, but it is the set of all points on a plane or a two-dimensional surface that are equidistant from a center point. And I even underline the word center because that comes up in the critical information of what a circle is all about. So every point of a circle is the same distance from our center point, all right? So we have a standard form equation. This is going to be the big thing you want to get down. This is like put a box around it, underline it. This is what you want to get in your notes. The standard form equation of a circle. We have x minus h quantity squared plus y minus k quantity squared equals r squared. Well, r shouldn't be too hard of a stretch of imagination, is obviously the radius. So whatever this number is over here, the square root of it is going to be r, because this number would be r squared. These values h and k make up a ordered pair, which is the center point that we talked about earlier. All right, so anytime I ask about critical information, you're going to want to identify both the center and the radius. Okay, so very quick, very straightforward example. X plus 3 quantity squared plus y minus 7 quantity squared equals 36. The h and k are always going to be these values that we see inside of our quantity squareds. All right, keep in mind there's no coefficients in front. And it was x minus h. So it's going to be the opposite here. So your center is going to be -3, +7. The h is always the x coordinate of the center point, and it's always paired up with your x variable, all right? So the -7 becomes a +7, and again, the k is your y coordinate of the center, and it's always paired with the y variable. Here we have equals 36, so your radius would be 6, the square root of that, okay? Pretty straightforward. If I asked for graphing this, which it's going to be hard to do via Google form, you would simply locate this ordered pair, and I would go up 6 units, down 6 units, left 6 units, right 6 units from that point, and then you have 4 points that you kind of have this little box around. Draw a circle that connects all 4 of those points. Now, you guys know that it's never that easy. I can probably sense you're cringing from here. So I promise you I'm not lying. This equation is an equation of a circle. And I'm going to ask that you identify the center and the radius of this circle. This is not, obviously not in standard form. So the goal here is we want to put this thing in standard form. So in order to do that, I'm going to use a 3-word phrase you might remember from Algebra 2 and Algebra 1. We need to complete the square. Okay, I'm offside a little bit. So when I'm completing the square, I want to make this long expanded version go back and look like something squared, all right, a simple binomial to the second degree. So the way we go ahead and do that is I'm going to do a little reordering. I'm not going to change anything other than the order of our terms. So I'm going to make the x squared and the 8x next to each other, with, again, like variables. And I'm going to put the y squared and the 4y. And I'm going to move that 16 over on the other side real quick. Okay. And what we see now is I kind of purposely left 2 blank spots here. And what we're doing is we're going to add a number so that we want basically those terms to be something squared. And again, we're going to add a number here that's going to allow us to factor into a pair of the same factors and make it something squared. And then we're going to have our radius here. So the way we do this, if you imagine a quadratic equation, we have ax squared plus bx plus c. This c number, we want it to be b over 2 squared. Okay, so if 8 is the b term, half of that would be 4. 4 squared is 16. Okay, notice this then splits into an x plus 4 and another x plus 4, which if we have the same pair of factors twice, that's exactly what we wanted. So we're going to put that as an x plus 4 squared. All right, I can probably sense some of you are probably like, whoa, hit pause, slow down. Let's just do it again, real slow. The b term here is 4. This missing term that's going to help me make this a perfect factored square trinomial, it's going to be half the middle term squared. Half of 4 is 2. 2 squared is 4. Okay? And I don't need the factoring, but I'm going to show it one more time. This is going to be a y plus 2 and another y plus 2, which factors into a y plus 2 squared. Okay? Now, here's the trick. We can't have a squared number be negative. So this negative 16 is still not quite done. We added a couple terms here to the left of my equal sign. So we need to always be careful to balance the equation. We added 16 on the left, so I have to also add 16 on the right. We added 4 on the left, so I'm going to add 4 on the right. And negative 16 plus 4 is, of course, 4. So now what we see is this is now in standard form. We have an h, a k, and an r squared. So my center, which is hk, again, keep in mind the negatives of those numbers. So negative 4, negative 2. And your radius, if this is r squared, is 2. Okay? If you want, take some time, practice these types of examples, because I can tell you right now, completing the square is a skill set that's going to come up every single section in this chapter. It's not just unique to circles. So it's definitely going to be a big part of what the types of questions you're going to see are. So if you're struggling with this, even after trying a couple problems after this video, reach out to me and we can set up a video conference, because this is going to be a very, very, very important skill set you want to work through. All right, good luck. Check out the homework on the course page and let me know if you have any questions.